Okay, students, in the first video, you have learned some simple things in R, how to generate random samples using inbuilt commands, a little bit of user-defined commands like this, both in vectorized form and using for loops. Now we are going to go for some advanced features. We have to simulate random samples using for loops in R, where your n from this normal distribution mu phi sigma square phi, where mu and sigma square are user defined like this. And in these user defined, we have fixed some parameters. For example, mu naught is going to be 0.5. It is predetermined. Sigma naught square is equal to. And y vector is this. Now first we have to find these two, and then using these two from the normal distribution, the mean for mean we are going to use this thing, and for standard deviation variance we are going to use this thing. We are going to select 100 samples by point using these two, and then we will do what is required. Now the $1,000,000 question is, we have to find this thing first or this thing first. Now if you see this thing in the mu phi, we are using sigma square phi. So we need this thing, and this is this thing. So first we need to find this thing, and then we are going to find this thing. Remember this thing. Mohim. Let's go to R. Okay. Now we have mu naught 0.5. Why 0.5? It is given here. And sigma square naught इससे अभी कम, आधा इससे अभी वाहिद. And y is 1 2 3 4 5 6 7 8. And and so we need what? First we need sigma square. Where is sigma square? This is given, this sigma naught square is given, but this sigma square and this sigma square we have to find using this sample. So we have find this thing here. We have find this thing. Let me see. We have to see sigma square. Is it there? Is it there? See now. What is the value? What is the value? It is sitta. It is sitta. Very good. Now compute sigma square phi. Why this thing first? I told you why this thing first. Because in these two Kawani, you see in mu phi we are using sigma square phi. So we need to find this thing first, and then we have to go for this thing. You get me? And this is فوق كم أس سالب واحد. So 1 over sigma naught square. This sigma naught square يساوي واحد. And هذا كم 6. So we need to find only this thing. So this على this زائد this على this and whole power minus 1. So there you are. So 1 over, why this 1 over this thing? Why? Sure. ليه هذا 1 over this thing? Because سالب واحد. سالب means يساوي ايش? It is 1 over this thing. It is 1 over this thing. Okay, why the sigma? Sigma square naught. Say 1 over sigma square naught زائد sum y min 1 hatta n minus 1. Min 1 hatta n minus 1 and square. Okay, so we have got sigma square pi here. We have done this formula. Now by using this thing, now we can compute mu pi. By overrun, multiply this thing, and then you have to do all this together. Phi cos mu naught يساوي صفر فاصلة يعني نصف على واحد ناقص this thing. So it is like this. Mu phi is equal to sigma square phi, this thing here, ضرب mu over sigma square phi sigma square صفر not زي كده sigma square not ناقص sum y from 1 to n minus 1 and 1 to 2 and y, because you know how to calculate this thing. You have practiced this thing. You have practiced this thing. You have practiced this thing here. You have practiced this thing. Okay. So we are going to put it here. Okay. So now we are going to use for loops. Very good. Initialize vector to store samples. So I am going to have 100 samples, and these 100 samples will be stored in samples, right? In a Murphy n samples, because here I have written n y, because n here we have used n for the length of y. So we cannot use n here. So it can be n something, n samples, 100. Okay, min 1, min I into 1 to number of samples, Murphy 1 to n, Zekida like this in the previous ones. Where Murphy like this, Murphy like this, Murphy like this. Because in this in this code we have used n for the length of y. Here we are going to use I min y at the number of samples, common samples 100. And what will be the sample I say r norm 1, because every time you have to generate one sample. How many samples will be generated? 100. And mean is average. Maaf is for y. This is mean is this mean. This mean. User defined. And where is the standard deviation? The standard deviation is what? The standard deviation is the square root of this, square root of this, square root of this. So mean here and standard deviation here, square root of this. And let us draw some sample. Let us draw the results now. The plot bar mfro C, one row and two columns. This is how to arrange plots in one row and two columns. So let's see now these two things, and I would like all of you to be very good in these things. Okay, I'm going to take all of these things here. So this is the trace plot. Yes, stationary. This is the histogram. Approximately normal. Approximately normal. With mean deviation in a minus 1.2, maybe a little more than this, maybe here. I don't know. You will see the values. But this is generally we can get an idea what is the mean. What is the mean? Okay, and let us draw the AB line. Let us draw the AB line. We can draw the AB line. Okay, so AB line. Okay, let's do it. There is AB line horizontal is plot this thing. Can we do it once again? Can we do it once again? Only one was very good. So sample, why sample mean here? We don't want a sample mean here. We need to have first we need to have sample mean, then we can draw this thing. Okay, let's do it. Also values are there. Okay, that's very good. So we have the sample mean here as well. The sample mean here. This is the mean of sample means. Mean of sample mean. Remember, these are these sample mean. These sample mean. These sample mean. You got what? these samples, these minus 1.12, minus 1.12, minus 1.12 sample. So we have to highlight the whole thing to get these values. These graphs are very, very important for you to study. Now, let us go for vectorized approach. Badoon using here we used for. Now we are not going to use for. So we are not going to use what the for loop. So again, same values, sigma, sigma square, sigma square phi, mu phi. We have to calculate this thing. Then will generate 100 samples using these two values, mean and standard deviation. And the same thing we are going to do. So I would like you to do the practice on both the things, So again, clear this thing and run this thing again. Then from this, you also are getting the same results. Okay. Now we have done this thing. Let's practice something more. We need to generate 100 samples from inverse gamma, where alpha naught and beta naught star is what 2 and 2. 2 and 2. Alpha naught star 2, beta naught star 2. Then plot the trace plot and histogram for the selected sample. Mean and variance are this. Find the mean and standard deviation of the 100 random sample selected. Note, inverse gamma is the reciprocal of gamma distribution. Y the gamma distribution. So we can use Y over R gamma in order to generate random numbers from inverse gamma. We are going to use 1 over R gamma and an AB, A and B, A and B, A and B. We don't have the Kanun for gamma, inverse gamma. You are going to study the Kanun for inverse gamma in the next lecture. Very important, very, very important. So let us see now. See here, mean of the gamma distribution is beta over alpha minus 1. So alpha has to be greater than 1. If you need the mean of gamma distribution, you need to have alpha greater than 1. But for variance, we need to have alpha greater than 2. Alpha greater than 2. So I have put here 2. So let's see what will happen. Should try something. Because here it will be alpha. If alpha not 0 is equal to 2, this thing. So what will happen? Let's see now. Okay. Okay. Inverse gamma vectorized approach. Alpha star and beta star 2, 2. Alpha star, beta star is 2 and 2. Okay. Number of samples 100. Seed 1 to 3 so that we can get the same results every time. Samples. We have to get the samples from inverse gamma. 1 over R gamma. Number of samples come Mia. Shape parameter. Shape parameter is alpha and rate parameter is beta star 2. So we are going to get 100 samples from this distribution, using alpha star, beta star 2. Okay, this is what is happening. So let us plot this thing first. This is our inverse gamma. Inverse gamma, we use inverse gamma for what? And where do we use it? Remember this question. We will answer this question in the next lecture. And let's go for the histogram and the density plot. Okay, it is mostly right skewed. Mean and sample mean standard deviation. We need the print. Okay, so 2.15, 2.62. This is from the simulated sample. These 100 simulated samples. these 100 simulated, right? 100 simulated. Okay. Now, if we are going to use the same thing for the R loop, so we need to have for is here. For is here. Do you get my point? And that is the case that we need to see. Now, let us go there. This is the last one. Here, alpha naught is here become this Mafi 2. Beta naught is what? Mafi 2. So it is also user defined, but this is also user defined, but a little complicated. So now we have to find alpha naught star and beta naught star. They are not fixed here. Mavi itna and itna. Here we have to find these values. So alpha star is Saviage. Alpha star is Saviage. We have got alpha naught. So alpha naught is there. Alpha naught. What was alpha naught? Alpha naught. Here he has given two values for alpha naught because these alpha naught and beta naught, remember, they have to be fixed. They have to be fixed. We have to come some values, some values, some values to this. So alpha naught, beta naught, let it be 2, 2. Let it be 2 and 2, 2 and 2, right? And I can mention here as well. And alpha naught is with nan and beta naught command is become is with nan. Okay, good. So alpha naught is with nan, beta naught is with nan. But alpha star, beta star, you have to find user this user defined function. Alpha naught plus n over 2. N is what? Length of this vector. Length of this vector. And beta naught is 1 over 2. And all these things, you have the y values and you know what to do in 1, 2, n minus 1, how to do this thing. You all know this. So alpha star is equal to alpha naught plus n over 2. So we get the alpha star. We get alpha star. Alpha not found. This means it is telling you to put all the things in one go. So alpha star is become Adasaba. And beta star is what? Beta naught plus 0.5. Why 0.5? In a 1 over 2. In a 1 over 2. Hada Isabi nis. But then sum y from 2 to n. Lay from 2 to n. Zekida. Y is equal to 1. This will be 2. Y is equal to 1. This will be 2. Remember this thing. It is 2, 2. And yn because it's n minus 1. It will be n. And y multiply by Salib 0.7 zerbe y from 1 to n minus 1. This is from 1 to n minus 1, from 1 to n minus 1, 1 to n minus 1, 1 to. This will be from what? 2 to 2 to what? Where? 2 to where? Remember this thing? 2 to n. So let us have the value for the beta star as well. What do we get the value for beta star? Beta star 32.8, very big value, very big value. Okay, need 100 samples. Samples, where to save these samples in this vector. For loop from 1 to n samples, 100. And we have to generate inverse gamma. Wide ala r gamma wahed. Wide le wahed. One sample each time, and there will be 100 samples. Shape parameter is alpha star. Rate parameter is this beta star. Of Hakaza, let us plot these values. Let us plot these values. You see, going down, of course, it is going to minimize. It is going to minimize because it has got something to do with variance. Something to do with variance. Okay, let's have histogram and density plots. Right skewed. Okay, going down. Right skewed and going down. This is what this thing is also telling it. It is right skewed. Okay. Then wait. We need sample means and we need to sample sorry, sample mean and sample standard deviation of 100 means. It will be 5.42 and 1.95. This is the sample mean and standard deviation. Sample mean and standard deviation. Okay. This is what we have done. This is what we have done. To get a smaller posterior variance, you need larger X, larger alpha and smaller beta, which means a stronger prior belief. I personally believe this note is not going to work here. For this note, we will be studying, we will be applying this note in our next lecture. Very, very important note. Very, very important note. The next topic will be Bayesian estimation, but this will be applied over there. Okay. Now, let us go for the user defined. There is another alpha, beta is there, alpha star, beta star is there. Okay. This is vectorized approach. Okay. And we get the same results. Do we get the same results? Let us check 1.95. Let us check. Get the same results. Yes, 1.95 approximately. Approximately. Okay. So remember, when we are drawing samples from inverse gamma like this is also inverse gamma like this. So we should be very careful in getting the values of alpha and beta naught. Here, in this case, the alpha naught and beta naught is 2, 2. But I am telling you to try this thing. Alpha naught is equal to 3 and beta naught is equal to 0.05, right? Because here, if you see the the standard deviation is 1.95. Okay. Now let's see if here is the last one. I should try to hurry. If it is alpha يساوي 3 or beta يساوي 0.005. Is it the same here? Alpha يساوي 3. Okay. So let's see what will happen to the standard deviation. Standard deviation. Overall it was come. Overall it was come. Overall it was 1.95. Now it has come what 1.44. So it has gone down. So if you want to have a smaller variance, so then this thing has to be kept in. You need a larger alpha and smaller beta, because if you apply this thing here, you will get the answer. You will get the answer. But this we are going to try in our next lecture when we will be studying Bayesian estimation. Thank you very much. Try this R codes and do your assignment, interactive assignment in the class to understand this thing. Take care.